First page of the second semester exam, practice exam. First part has to do with names and formulas. Lots of strategies you could try. You could just go one by one and figure them out. What you might want to choose to do though is just, since this first part is dependent on whether they're ionic or molecular, you might want to go through and identify which is each, and that makes you understand a little bit that ionic are the only ones that have charges. You're going to have to crisscross. You don't do that with molecular. Molecular simply have the prefixes, which are written underneath there. So you might want to go find all the ionics. How do you know ionics? Well, the ionics will have a metal, or they're going to have that one on the back called an ammonium, which is a +1. Ammonium, which is a +1 over here. So let's just go through, and if I can figure out which ones are ionic, I might know which ones need to be crossed. Starts with a metal, ionic, metal, ionic, metal, ionic. How about potassium? It's also a metal, ionic. Ammonium is that one, it's NH4, it's ionic. Here we have carbon. Carbon's a nonmetal. Nonmetals are molecular compounds are nonmetals to nonmetals. Also, the other hint that it's going to be molecular is the tetra. It has a prefix. None of the others I've looked at so far have tetra. So I'm going to go through this column. Well, I'll do the easiest one first. Carbon tetrachloride. There's no crisscross, there's no charges. It's simply saying that there's one carbon. They don't tell me one, but it's implied. And chlorines has a tetra. We'll find tetra, it's a 4. CCl4. All the rest of these are ionics. All the rest of these I have to crisscross the charges, oxidation numbers, to make sure that I have the right number of each one. For instance, copper. They're telling me it's copper 2. That's a copper with a +2 charge. Sulfate, I'll find on this side, I'll have to search for it. Found it. SO4 -2. SO4 -2. I call this a match made in heaven. This one needed to lose 2. This one needed to gain 2. It only takes one of those and one of those. Copper sulfate, CuSO4. Iron 3 chloride. Same drill. That Roman numeral for iron tells me it's got a +3 charge. Chloride only makes -1 charges. Here it's going to take 3 chlorines to balance off just one iron, FeCl3. Notice it does not have 3 irons. Iron 3 refers to the charge. Aluminum oxide. Aluminum always makes +3. It's in that column. Oxygen only -2s. It's going to take 3 of these and 2 of these. Al2O3. Potassium, phosphate. Potassium's in a column with a K +1. Phosphate I find back here. Search. There it is. PO4 with a -3. PO4 with a -3. It means it's going to take only one of these, but 3 of these. K3PO4. Ammonium carbonate. Ammonium is that one strange one on the back. Ammonium, I had it circled. NH4 with a +1. Carbonate's also on the back. It is a CO3 with a -2. So we have an NH4 with a +1 and a CO3 with a -2. Well, it's going to take 2 of those. There's going to be some parentheses required. NH4. I need 2 of them, so I need parentheses. CO3. Ammonium carbonate. Slide this over. Darn. Okay, I'm going to erase those answers for now. There we go. Okay. Sodium chromate. Na with a +1. Chromate is CrO4 with a -2. How do I know that? I looked back here and found chromate CrO4 with a -2. That means it's going to take two of these, Na2CrO4. Silver. Silver looks like a transition metal. It's sitting in transition metal land, but I clearly wrote on there that it's got a +1 charge. Silver is Ag with a +1. Sulfide, S with a -2. S with a -2. That means it's going to take two silvers, Ag2S. Zinc nitrate. Zinc. Once again, I tried to clearly write it. That is a +2. Zinc makes +2 charges. And nitrate is NO3 with a -1 charge. It's going to take two of those. This is going to require some parentheses again. Zinc, only one of them. It's going to take two nitrates. Strontium, Sr with a +2. Let's double check. Sr with a +2. Fluoride, F with a -1. It's going to take two of those and only one of those. SrF2. Magnesium, hydroxide. Magnesium, +2. Hydroxide is OH with a -1. It's one of those ides that isn't on the nonmetal ide side. It's back here, hydroxide. So it's, again, going to take two of those, and that's going to require some parentheses. MgOH2. How come only one of those? Because when I crisscross, one Mg and two OHs. Phosphorus tribromide. Here I see a prefix. This is a molecular. Since this one is molecular, there's no need to check charges. It's just phosphorus, P. It didn't tell me there was more than one, so there's just one. Bromides are BRs, but it's tribromide, BR3. On to the bottom section. Just doing the same in reverse. We are writing the names for the following compounds. We might choose to go through and figure out which one of these are molecular, because that might help us understand whether or not we need prefixes. It starts with a metal, it's ionic. Metal, ionic. This one's a weird one, probably won't even show up on the exam. It starts with a non-metal, even though it's looking over there, so this is technically molecular. It's a metal, ionic, S. S is a non-metal, that's sulfur, so it is a molecular. N is also a non-metal, it's molecular. Sodium's a metal, that's ionic. Sn is tin is a metal, that's ionic. This is one of them strange, when we see multiple stuff like this, these polyatomic ions, this is ionic, and this is ionic. Maybe I do the easier ones first. All the moleculars are easier. You simply use those little prefixes to tell how many of each thing. Since molecular, I have two of each thing. Di2, dihydrogen, dioxide. Its normal name is hydrogen peroxide, but we're going with dihydrogen dioxide. Go to another molecular, SCl6. That's sulfur, and that's chlorine, which becomes chloride. And I got 6 of them. Let me go find 6. It's hexa, sulfur, hexachloride. There's only one nitrogen, so I write nitrogen. But there's 3 oxygens, that's trioxide. All the rest are the type that had to be crisscrossed. All the rest are what are called ionic substances. Ionic, you simply give the name of the metal. This one's copper. Little caution though, on the ionics, some of these things need Roman numerals. Which one needs Roman numerals? Well, pretty much all of these, except for the ones that already have a plus in them, and these ones. So if they'll need a Roman numeral, that Roman numeral tells what the charge of that particular atom is. So copper's up there in this area. How do I translate this? if it's copper with a plus question mark, because we don't know, getting with nitrogen with a -1, how do I know that? It's on the back here. Nitrogen, -1, or nitrate. If there were 2 of these, but only 1 of these, this must have been a +2 charge, because this is a -1 charge. I would have to put copper 2 nitrate. The next one isn't as complicated. Next one, because barium comes over here in predictable land. Where's barium? Over here in predictable +2 land. We don't have to tell anybody it's charged, because everybody knows that, or they can see it. It's simply barium chloride. No prefixes on ionic stuff. Next one, nickel. Let me check to see where that's at. Nickel's over here in transition metal land. It's going to need a Roman numeral. So on the surface, I might think I could simply call it nickel hydroxide. But in reality, I'm going to have to figure out which form of nickel do we have here. Nickel plus question mark. Well, if it's with an OH with a -1, because that's the only thing they make, once again, the same sort of crisscross. If there were 2 of those, that's because nickel was +2. Nickel 2 hydroxide. Sodium chloride, that one everybody knows. Next one, on the surface looks simply like tin bromide. I know some of you want to say tetrabromide, but it's not. Tin, this is just a molecular or an ionic substance, and ionic substances don't have prefixes. So I have to figure out which version of tin. It's tin plus something. It's with Br -1s, and there's 4 of those. That must mean it must be tin 4 bromide. That's the Roman numeral IV. Next one, ammonium, because that came from back here. I've got to find now those other things, which are C's and R's and O's and 4's. Where did those go? Wow. C's and R's and O's and 4's. I'm going to find those. There they are. Chromate. Ammonium chromate. And finally, magnesium. That's just its first name. Don't need a Roman numeral. NO3, we'll find on the back. NO3 is nitrate. Last section. Write and balance these equations. This is just one of those magnesium hydroxide. That's base. And it's reacting with an acid. And since we don't know our acid rules, the formula is given. If I really take HNO3, acid plus a base, magnesium hydroxide, I got to make sure I do this right. I'm going to just scrap paper. Magnesium's +2, OH is a -1. You're going to need 2 of those to make it correct. When it's done, it's going to make salt and water. Which salt? They even tell us the name of it, magnesium nitrate. So I can do a magnesium +2, nitrate, NO3 -1. It's going to take 2 of those. So water and MgNO3 taken twice. Next step. The things that we're counting here are hydroxides, magnesiums, and nitrates, and hydrogens. That sounded confusing. I'm not going to draw a little chart for this. I'm just going to look and say, since I got 2 nitrates over there, I'm going to need a 2 over there. Since I now have 2 H's and 2 OH's, sometimes I write this as HOH. It doesn't change anything. It just tells me I need 2 of those. That is all balanced right now. The combustion, another one we're familiar with. Combustion, you take a hydrocarbon, usually something that has lots of C's and H's. You react it with oxygen, and it either is going to go complete or incomplete. This one happens to be complete. They tell us it's carbon dioxide. or else we're going to get water vapor. Its reaction is exothermic, include the energy. Well, if it exits, I just put energy over here. It doesn't tell me how many kilojoules, but that's what I would put there. How do I balance this? Since there's 2 carbons here, I better put a 2 there. Since there's 6 hydrogens, I better put a 3 times 2 is 6. Now when I count up all of my oxygens, I'm going to have a problem. The problem is I now have 7 oxygens on this side, but only 2 oxygens on this side. Now, if it were legal, I could write 3.5 there. 3.5 times 2 would give me 7. That's not quite legal, so now I'm going to go back and double everything so that I don't have this. I need an integer there. So, if I multiply this by 2, and this by 2 to get 7 oxygens, and this by 2 to get 4 carbon dioxide, this by 2 to get 6, I now have a balanced reaction.